We just finished talking about demographic transition. So let's look at some more specific information about world population growth. This graph right here is showing the human population size in the largest populated countries globally. The top three right here you can see: China, India, and the United States. So you can see that by looking at the bars, most of the bars are blue, which means our highly populated locations are going to be mostly developed countries. Okay, so it is mostly mostly developing countries. We have three in the top list that are developed. So China, United States, and India. Now, if you look closely right here, guys, India is about to surpass China as being the most populated country in the world. So it is projected that India will surpass China in 2030. That is only 10 years away, guys. It's kind of crazy to see how things have shifted. China historically had the one-child policy, which greatly curbed their population growth. But they have since done away with it. And because of that, it hasn't really impacted their population, surprisingly, because they did this for so long that it's become ingrained in their culture. All right. So this graph right here is showing us projections for population growth. Okay. As you can see, here's 2020. We are right here. And this graph, even though it's a prediction, is pretty accurate to what our current population is. We're closer to 8 billion than we are to 7 billion. By 2050, we'll be above 9 billion. So the question is, when we look at this, when do we reach K for humans? When do we reach K? Remember, what's K? K is carrying capacity. So at what point is the Earth going to reach carrying capacity for human populations? Will we have a massive population crash? We're currently seeing a big shift in population size because of coronavirus, but are we going to run out of resources at some point that will cause a massive population crash? I'm just curious what you guys think about that. All right, so moving on to our next image. Here we have, this is our ecological footprints. You guys calculated this a while ago. Ecological footprints for several different countries. All right, now our global average is 2.7. That's the global average. And as you can see, there are several countries above that. The United States obviously is the highest. We use the most resources and we have the highest footprint. Australia, surprisingly, even though it's a small country, it is a developed country. So they are going to have a higher footprint as well. So, most developed countries have higher footprints. And it is because they consume more resources. Consume more resources and produce more waste. You can just look at the way most people live in the United States and it makes sense. All right. Now, this graph is a theoretical one, and this is what we call the Malthusian catastrophe. Malthusian catastrophe. Catastrophe. Remember in the graph we just looked at, I said, when are we going to reach carrying capacity for humans? Well, this graph attempts to show that. So Malthus was a researcher who believes he has calculated what's called the point of crisis. Okay, the point of crisis. So you can see right here, we're having massive population growth. Oh, and look, guys. What does that look like? It's a J-shaped curve. And what does a J-shaped curve means? It's exponential growth. So the human population has, we know, exponential growth. So at what point are we going to run out of resources? That's called the point of crisis. Okay? Have we reached that? When are we going to reach that? So, the Malthusian catastrophe states that population growth is exponential. But food supply is linear. We can only produce so much food based on the natural resources the planet has. Okay? The crisis point is when we have more people than available food. So at this crisis point is where we're going to see a massive population crash. Okay? So that's the Malthusian catastrophe. All right. Shifting to the next page, urbanization. So urbanization is obviously going to be where we have large cities. So these are going to be very densely populated locations. A lot of people live here, a lot of people work here, a lot of resources are consumed here. All right? So urbanization is basically city development. When cities are developed, we're going to have a lot of materials put in place that are damaging to the environment. So, we know that urbanization leads to a depletion of resources because we're using lots of fossil fuels, metals, to build the infrastructure that's needed here. All right? And it affects the carbon cycle. The unit we're going to be in next will talk more about the carbon cycle. But think about how many fossil fuels are burned here. So this is going to add more add more carbon to the carbon cycle. So it affects the carbon cycle by the burning of fossil fuels. So you have lots of cars, you have lots of factories in these locations that are going to increase the carbon dioxide output into the atmosphere. Okay, this also is going to impact the water cycle. So think about a grassy area versus concrete. Which one of these is more porous, meaning which one of these is going to absorb more water? Obviously, the grasses. Water tends to sit on top. So this is more damaging to the water cycle because the water is not going where it is needed most. Okay? So we say that impervious surfaces. Impervious means that water cannot get through it. Impervious surfaces do not allow water, that's my H2O, to reach the soil. Okay, so what does this do? It increases flooding. And we've seen lots of issues with that in Houston, particularly when they get lots of rain. Okay, so an example of an impervious surface is obviously going to be concrete. Water cannot go through it. Okay. All right. Lastly, this picture shows what we call urban sprawl. Urban sprawl, 1984, 2016. This is the same aerial view of the same location. You can see that 2016, there's obviously a ton more development, especially out here. This is what we call urban sprawl, when you have a major city spread into the neighboring countryside. Okay, so you have what we call spread into rural areas. Rural meaning countryside, farmland. Spread into rural areas. Okay. We also know that this can lead to environmental problems. As we noticed above, it's going to impact the carbon and the water cycles. So at this point, guys, we have reached the end of Unit 2. So we've learned about population ecology, we've learned about human population growth and the aspects that impact it. We will have a test coming up on this unit, so please make sure if you have any lingering questions about any of this content that I've been teaching you, please reach out to me and let me know. Thanks, guys.